This is the applications and the conceptual development problems. We'll work those out so you can see them. All right, so again, anytime you see this phrase, average rate of change, you guys should know that we're looking for the slope. So we're going to use the slope formula. M equals y2 minus y1 over x2 minus x1. So to use the slope formula, we need 2 points. All right. Now, to get those 2 points, it's asking for the rate of change, average rate of change of height, over the first 3 seconds after being shot. So, we need to find out where it was at the beginning, so it's 0 time. And then we need to find out at the end, which would be time was 3. All right? So, what we got to do is plug the 0 into our formula. When we do that, this becomes 0. This becomes 0, so it just leaves us with 2. So we get this point for our first point. All right? Again, 0 time, its height is 2. All right, so then after that, we got to plug the 3 in. Now, so we'll plug the 3 into the formula. So we're looking for h of 3. So it looks like this. Plus, all right, 46.5 times 3 minus 3.5 times 3 squared. All right, that's what it's going to look like. All right, so we just plug it into that formula, plug the 3 in for the t's, and when we do that, we get h of 3 equals 110. All right, and that gives us our 2 points. So now all I got to do is plug these 2 points into our slope formula again. X, y, x, y. 110 is bigger, so I'll make that 2, 2, 1, 1. And we get that m equals 110 minus 2 over 3 minus 0, which gives me 108 over 3, which is equal to 36. So the average rate of change is 36 meters per second. All right, so that's that first one. All right, this is the one I told you about. This is just like the worksheet, the homework worksheet we had the other day. They give you that there are 3 real zeros at -5, 2, and 5. You can probably plot those right off the bat if you wanted to look at this graph. So we have -5. We have 2, and we have 5. All right, and leading coefficient is negative. This 3 zeros tells you that it is 3 real zeros, exactly 3 real zeros. That tells you that the degree is 3. All right, and the leading coefficient is negative. So again, it's my negative friend who disagrees with me. So when I say positive infinity, he says negative infinity. When I say negative infinity, he says positive infinity. So you can pretty much get an idea of what the graph looks like. So that's easy to do, the graph. The other thing you're going to have to do for this is you're also going to have to write the equation. All right? So I want to know what the equation is for this. So it looks like this. We have x equals -5. Well, we add 5 to both sides, and that would give us x plus 5 equals 0. So that's one of the factors, and that came from here. So we got x plus 5. This would give us x minus 2, and this 5 would give us x minus 5. All right. Now, it also tells us the leading coefficient is negative, so I'm just going to put a -1 out front. All right. And that is the general equation, but now you have to multiply all these things out and multiply them all together. So what I did is I just multiplied the first times the last because these are the difference of 2 squares. So that gave me x -1 x squared minus 25 times x minus 2. All right. And then after I did that, I just FOILed it out, that out. When I FOILed this out, that gave me this. X cubed minus 2x squared minus 25x minus 50. And then I just got to put the negative 1 in there. All right? Or plus 50. That was a plus 50. All right? And then, yeah, I just got to distribute my negative 1. So I get y equals negative x cubed plus 2x squared plus 25x minus 50. And that is my equation in standard form. And again, I'm looking for your equation in standard form.